The mean value of a function is not always the best number to characterize the function. And then sometimes root mean square is a better number. Let me give you some example. Consider the function y is sine of x in the interval 0 to pi. The function looks like that, and if we consider the mean value, then it will be 1 over 2 pi, integral from 0 to pi, sine of x dx. We can find an antiderivative, which is minus cosine of x from 0 to 2 pi. But this function is periodic, and at 0 and 2 pi gives the same value, minus 1. And if we subtract these two identical values, the result is 0. This can be also computed using, or found using the graph. Because when we integrate the function, then for x values where the function is positive, these positive values contribute some positive contribution to the integral. But then, when the function is negative, then this positive contribution is consumed and the total integral gives 0. If you think of the y being velocity and x being time, then positive velocity means you move in some direction, and then the negative velocity means you move back. And the area of this hump is the distance that you make forward, and this is the same area but going backwards. So you end up at the initial position, and the change in the position is 0. Sine is a typical function that describes, say, alternating current that comes to your household from electricity station. So 0 is not a good value to characterize the energy, the strength of this signal. And then we use the root mean square. That means before averaging, we first square a function, then we compute the average, and then we take the square root to get the same physical units. So instead of considering f average as 1 over b minus a, integral from a to b of the function, we first consider f square, then we average this, meaning integrating from a to b and dividing by b minus a, and then we take the square root of that. And this is called the RMS, the root mean square of the function f. Alternatively, you can write it as f squared average square root of that. Let's consider the root mean square value for the function sine. So that will be square root of 1 over 2 pi, integral from 0 to 2 pi, sine squared x dx. But we have seen that sine squared, when integrated in nice limits, that means when the limits are integer multiples of pi half, is equal to integrating 1/2. And integrating 1/2 from 0 to 2 pi gives half of the difference of the limits, which is pi half, which is pi. We can reduce pi, and we have square root of 1/2 or square root of 2/2. So there is some value, square root of 2/2, that has the meaning that the average, the square of the function has the same effect as the constant function with this height. When we go back to the y meaning electric voltage, then this value is called the effective voltage, and this is the voltage of a constant current that makes the same heat on some constant load. Square is quite useful, not just because it gives the positive and negative values to contribute instead of decrease the integral, but square has also quite an important meaning in physics. Square is often a very important function that gives you the energy, the meaning of some signal. Say, if you have a car accident, then the kinetic energy 1/2 mv squared must be consumed, must be dissipated in a fraction of a second, and here we have the square of the velocity. So this is the important quantity. If you have the electric current with voltage U in some resistor R, then this is the current, and multiplied by the voltage is the power. So you see the power is again proportional to square of the voltage. So this is the root mean square, the square root of the average of a square of the function, which is often used to characterize the strength, the energy described by some function, especially when the function changes its sign.